Assalamu alaikum and welcome everyone. Today I will again discuss about the data flow diagram, which is a flow-oriented diagram. And this data flow diagram is a very useful tool for the uh, designer, analyst, programmers. So we'll see the data flow diagram is basically available in our seventh edition book of the Roger Expressman, but it is not available in the 8th and ninth edition. So as this is a very valuable tool, so that's why I want to discuss this with you and want to share the idea about the data flow diagram, and it's really interesting one. So data flow diagram is basically a graphical representation of the flow of data within the system, and it tells us how the data flows from within the system from one process to another processes, and how it works, what it behaves, and all these things actually shown into the data flow diagram. And as I said, it is the very powerful tool used by the designers, programmers, the analysts to see the actual information movement or movement of the from the process to processes within the data within the system. So data flow diagram also has different components like all other diagrams, because the use case diagram, swim lane diagram, activity diagram, or even the flow chart or the entity relationship diagram. But all these diagram has got different components and different symbols. So same way the data flow diagram also has only four main components, only four symbols were used over there. One is the process, data store, data flow, and external entities. And I say that data flow diagram is basically a iterative game, because all throughout the activities, it is the same rule is applied, and it goes up to the last level. We follow the same rules. So in the data flow diagram, we use these two different type of symbols, which is Marco and Jordan symbols or Jane and Sampson symbols. So external entities symbols is like a rectangular box, or Marco use a, sometimes they use a square boxes over there. Jane and Sesser use this one. Process here they use a circle, and they use a cutting edge uh, square box. For the data store, two parallel lines were there in the Yodron symbols, but Jane and Sepsum symbols, it is a two parallel line with a connecting line is there. So it is something like this, and data flow is the same. So only the little different is into the process and the symbols. So as a uh, designer, we have to follow either the Marco and Yodron symbols or Jane and Sem and Session symbols. We cannot mix these two. Okay, so that is one of the rules which standard we have to follow. And as I say, the data flow diagram is like a game. It's like in a game, what happened in different computer games, we have different levels, level one, level two, level three, and we have to do the same thing. And our level is getting more harder. So here, it is not more harder, but it is more complex, I would say, because we try to start with the level zero, which is also called the context level diagram. And in context level diagram, the whole system represent into a single process, which is a context level diagram or level zero diagram. Then we decompose it, or we break the context level, and we get the main core subsystem of the main systems, which is in level one. Then from level one, we go to the level two. In level two, we decompose each of the processes we received in level one. So we decompose it, and or we break it into break each of the processes and get more processes out of it. So in this way, we can go to the level three, then level four, level five. Actually, you can reach to the level n. So we cannot say that my DFD ends up into level two. It can go up to level three. Someone can go to level five. Someone can go to level six. So it depends on different system to system. So let's see how actually it works. So as I said, that it is a level 0 where the whole system is represented by a single process, and this system is connecting with some external entity, which is a rectangular box or a square box. So, and this one can be one tells that how many entities are connecting over there and how many external entities are getting the output of it. So it's basically how many inputs were there and how many outputs we are getting. So we may have multiple external entities over there, but the system is only the whole system represented by a single circle. Then we move to the level 1 where we decompose this system into 1, 2, 3, 4, 5, 6 sub-processes or key processes. And these key processes are actually communicating with each other maybe. So in this way, the data flow actually tells that how it is communicating with each of us for each of the processes. And if you look into the level 0, we have one input and one output. So it may be in some of the processes we have this input, and from some processes we got one output over there. So in this way, we have this one. Maybe we may have a data store which is used over there, which is a two parallel line, I said, because I use the Marco symbol. So we can use a two parallel line for the data store. There are so multiple parallel lines over there. So it would be like this. And then if we go to the level 2, where we actually decompose all the processes we get into the level 1. So level 2 of process 1, then level 2 of process 2, level 2 of process 3, process 5, process 6. In this way, we can go to the process n, because here I got only 6 processes, so we can uh, break it down to the level 2 into the up to the process 6. So if someone gets 7 processes, so he or she will go up to the process 7, if 8. So it depends on the system. Then what will happen? We also use some numbering over there with the numbering so that we can take a uh, uh, connection between each process, one process to another process. So we can use the name as well, but maybe sometimes it is difficult. But if we use this numbering, so we can actually find their ancestors or they are linking to their next generation processes or next level processes as well. So it is a good practice to use this numbering. So process 1.1. So if I break process 1, I got process 1.1, 1.2, 1.3, 1.4. This process can be decomposed into the four another sub processes. So I got four. For process 2, it can come maybe if we decompose it, I can get maybe 3 processes were there. So it depends that how many processes are inside each of these processes into the level 1. So same way, these processes are communicating with each other. These processes are communicating with each other, and also this process uh, tells that how actually will work and how this process will communicate with them. So these sort of processes, I can go to the further level, which is level 3, which is level 3 of process 1.1. So I can break all these 1, 2, 3, 4 processes into the level 3. Then I can go to the level 4. I can go to the level 5 until I reach to a level from where I cannot decompose or break the processes into the further levels. So that is the end of this journey. Then, so it has to be done for all the processes, and we go up to the last level. So that is a iterative game. So that's why there is nothing new in it. It is the same thing what we have over there, and that's why I said it is an iterative game. So if I take from our book, which is this one, in the safe home software, what we had. So this is a context level diagram. The whole system is representing by a single system. and it has 5 different external entities. So we have 2 inputs, these 2 external entities giving inputs, and it's generating 3 outputs, which is going to 3 different external entities. So, and this is the data flow. This is not the parameter. So we know about the parameter, we can send A, comma, B, comma, C, but it's not like that. It is actually the data flow, the what type of data actually we are passing from external entity to the system, or system is generating what type of output for here for the system to the external entity. So this is a zero level diagram or context level diagram. So if you see the book also, this says that this is a context level diagram. It is the fast data flow diagram where the whole system is represented by a system. So the Bible is also telling us the same thing. Then into the level 1. So from level 0 to come to the level, if we break this one or decompose this one, we got this 1, 2, 3, 4, 5, 6, 6 processes. And this tells us how these processes are connecting with each other. And also there is the data store is there. So these data are 2 parallel lines. So this data store is connecting which processes, which data process is storing data over there, or which process is receiving data from the data store. So it is a very pictorial description or drawing system of the whole system. If I break it, so it would be something like this. It has 6 core systems. Then if you go to the level 2, where we actually break the monitor sensor process, so which is this one, the monitor sensor process. Monitor sensor process, we decompose it or we break it into the further level, which is level 2. And we got 1, 2, 3, 4, 5 sub-processes. And also whatever the data connections or in number of inputs and outputs, they have to manage from there. So if you go back to the rule, so monitor sub-process contains 1 input or from there, another input from the data store, and it is generating 3 outputs, 1, 2, and 3. So if we go to the level 2, we see this contains 2 inputs. So some of the processor has got input. So one input is coming from the data store, another input coming from the external entities, and it is creating 3 outputs. So this process creating 1 output, this process creating another output, this process is generating another output. So as a whole, this is this monitor sensor process. So this is how actually we can decompose it, and then we can do the level 2 DFD for all of these processes. So we cannot do only one process. So all the processes will do the same thing. So it is an iterative process. Let's explore another one. So this is a online shopping system or e-commerce systems DFD. Same the context level DFD, because the whole system represented by a single process, which is a single circle, and we have 4 external entities are there, and it says that what type of output it is generating, what type of input it is taking. So this data flow is telling that data is coming from where and going to where. So if we decompose it, we got 1, 2, 3, 4, 5 processes or sub processes, and this is communicating with the data store, and they are also communicating with each other in the same process. Then from level 2, so once you move to level 1 to level 2, so same way we take one of the sub processor, we break it to more further level. So we took online shopping master, that process, which is this one, online shopping master module. So this one. So if we take this one, so once we break this one, we got 1, 2, 3, 4 sub processes over there, and they are also communicating with the system. And the rules are same. The number of input output should be managed by should be same or similar to each of these levels. This is another one, which is the order processing system. So if we see the order processing system, which is order processing module. So this one is actually, this one, it also generates 4 different outputs are there. And if you look into this model, they did not make this numbering, but it is a good practice if you give the numbering. so that we can easily identify their ancestors or their next generation model. So we can follow this number instead of remembering the name of the processes. So if the journey is same, so it is actually we have to complete all the processes from level two from level one, then level three, then level four, then up to level n, because I have to decompose it until we cannot move into the further level. So uh, we have to go to end, stop our journey at the end, at the level where from where we cannot break the process into another level. So that is the end point of this. So that's why it is level n. It does not stop into level three or level four. So it depends on system to system, how actually we are analyzing the system. Let's see another one. I took this one to give you an idea. So this is basically a level one because there are so many processes over there, and it is our Netflix data flow diagram. Okay, some I took it from the net, but to show you that we use symbols, which is the Marcos symbols, but the data store is Jane and Serson symbols, which I have already said. We have to use this standardized symbols. So either you have to follow this one or I have to follow this one. So in the draw.io, we have this, and if you say use the Lucid chart or other charts, you have all these things. Smart Draw also have these symbols as well. So in Figma, it also you can do it. So it is correct, but it is actually not to the what to say the symbol standard it violates. So it has to be two parallel line. It has to be a parallel line instead of a box line. So then it is okay. So we have a parallel line, so that tells that it is okay. So this is the thing which we have to follow and we have to maintain. And in DFD, there are another two things we actually get and we also generate. One is P-spec, another one is C-spec, which is process specification and control specification. Process specification actually defines each of the processes of the system, and control specification actually define the control moves or within the system or how the control behaves into the system. So these two things is the actually we get or we generate from the DFD. And this spec also generates two diagrams. One is the state diagram and sequence diagram. And most of them actually how the behavioral changes of the system into the how it behaves from one process to another process, how the control moves. It shows into these two diagrams. So in sequence diagram, we already said we have some objects and actors are there, and we use different lifelines and how the system control moves from one homeowner to control panel, so to a system, control panel to system, and from there to the sensor. So how it moves from one place to another place into a system, it is very easy to identify, and we can see these things over there through a sequence diagram, and we can represent it, this type of behavioral changes through the uh, sequence diagram. We can also use the state diagram where the state moves from one state to another state. It moves, so it has the three parts: the state name, then state variables are there, and the state activities. And state activities are basically we have an entry activity, do activity, and exit activity. And and this state diagram is also a behavioral diagram that how the control process behaves by with this input and when it will work move to another state. So all these things are basically done in a spec part. So the how the control moves basically into the system. So DFD, that's why it is very popular to the programmers world. And to be a good programmer, if you want to be a good coder, you need to know how to play with the DFD. And DFD will give us an idea how to how the system works, how the system will behave, okay, what type of input are required, what type of output it will generate, and it gives us an overall idea about it. So I would say that it is very interesting and very easy. So let's learn and enjoy the processes. And I wish the DFD, once you understand the whole process of the DFD, you will enjoy it and you will draw in front of your table on the whiteboard or on the glass door. So it is, if we visit to different software organization, we see the programmers, they used to draw all these sort of symbols in on their table, wall, or whiteboards in their room, and they love it, and they can code with a full of enjoyment. So that's all for the DFD. I wish now you are more familiar with it, but it needs more practice so that you know how to decompose it. The more experience you have, you will decompose the thing more properly, and you will code also accordingly. Thank you all for uh, this session. Inshallah, I will come up with another session with another topic. Thank you all.